Hi, welcome back to the Schiko Statistic Lecturing Series. And in this lecture, we talk about the random variables and the distribution. So this is the video number 2 about this lecture. We talk about the continuous random variables, and we talk about this probability density function, the PDF, and the CDF. So we discussed the definition, how to find the probability, and what is the relation between the PDF and the CDF. All right, so we did 3 problems as practice, and now this video is basically to follow the same concept like the previous video, and we're just going to do more practice. So how to change from the PDF to CDF, CDF to PDF. You know, this is extremely important because you need to be good at it. Because later in the next lecture, we're going to talk about joint density function. So the joint density function, that means you have 2 variables. Right? How do you find the PDF? How do you find the CDF? So that's why you need to be have a strong backgrounds. So then you can be able to get, so if I extend it to the 2 variables, 3 variables, should be the same thing. So it should be easy for you. Okay, so now let's take a look at the problems here. We already did the previous, 3 problems. Okay, so let's take a look at these ones here. All right, so you talk about the probability density function of a continuous random variable x is given by this, and I want to draw a picture and remember, so here, the first things here, let's try to do a brief reviews here, right? So because if it is like the PDF for continuous random variable, so what do we say here? So we said if you integrate your PDF f of x dx is equal to 1, right? So that is the one very, very key thing, even when we started the sample space. So it's the same thing, including all the things in the domain that has to be equal to 1. Okay, so now let's take a look at this ones here. The PDF is giving us is 1/5 from the x is from 2 to 2 to 7, right? So let's try to take a look at okay, so this is 2, this is 7, right? And then because the f of x is equal to 1/5, so if this is the 1/5, that means here inside the ranges here is from the 2 to 7 is all 1/5. So this is the PDF, right? So this is my f of x here. So this is the PDF. And this PDF, in fact, when we go to the later lectures, we call this PDF, we call these uniform distributions. That's we'll talk about that later, but we know this is a PDF. So the first thing is here, we say, okay, I need to find the area under it. Is this is equal to 1, right? So, when you integrate the PDF from the negative infinity to positive infinity, what's that mean? That means you can also say this is the area under, right? So this is the area under the f of x. That's what we did in the calculus. We said integration, the definite integration is really is equal to you find the area under the curve. Okay, so now in here, let's take a look here. So that means in here, so I'm going to find the area. So this is the area under the curve, right? So one thing here you can do, of course, you can use the integration, or you can just say that, okay, this area is here. What is this area? This is rectangles, right? So it's length times height. So it's 5 times 1/5, right? Because from the 7 to 2 is 5. So this is 1. All right. Or you can just use a simple integration. You say it's 2 to the 7 and 1/5 dx. So what is 1/5? It's a constant. So when you take the integration, it's 1/5 x, and this is 7/2. So you will get 1. It's the same thing. So we say, okay, this is what, the first part I asked you, right? So the total area under the curve is equal to 1. So that means it's satisfied to be the probability density functions for the random variable x. And then now I'm going to find the probability from the 3, x is from the 3 to 5. So in here, the part B is here. So this is the probability, the 3 to 5, right? So of course you can say, okay, this is just will be the integration from the 3 to 5, then 1/5 dx. Remember, that's what we defined. So if you go back, I think here, right? So this is the very, very important, right? So this is the key, very important, right? So if you find the integration, so that means you find the area between A and B. That means you find the probability of random variable between A and B. So it's the same thing we discussed on our first video. Okay, so let's go back here. Okay, so now in here, so then here you can say this is 1/5 x, and 1/5 is the constant, right? So integration is easy. So it's a 5 to 3. So you can just put a, sort of 5 to 3 is here. So it will be, so what, 5/5 minus 3/5, right? So it will be what, 2/5. So that would be the answer. Or, if you can look at it directly from the area pointer, right? So it's the same thing. So you say, okay, so this is a 3, right? So this is a 5 here. So when you try to find the probability of the 3 to 5, you basically you're looking for this green area. So what is the green area? So the green area is what? Green area is 2 times 1/5. So it's the area of a rectangle, right? So sometimes, if your graph is easy, then you can use the graph to find the probability. It's a lot easier than take the integration. And this one, the integration is not that bad. So I think you can, it'd be okay. So either way. Okay, so now let's take a look at the next problems here. Okay, so so this is the problems here. They give us the PDF here, right? So f of x, the lowercase is PDF, is 1/3 when the x be from the 0 to 1, and 1/3 from the x to 4, and 0 otherwise. So the first things here they want us to do is to find, to do the graphs, right? We need to do the graphs for the probability density function and the probability distribution function. So it's the CDF here. So we want to find the PDF and the CDF, right? So here, this means that I want to find the PDF, and this here is I want to find the CDF, okay? All right, so let's take a look, right? Let's take a look at the PDF first. And this is, I like this problem. This problem is a very good problem because even when we did a discrete, right? We said one of the most important things you need to know about the CDF and the PDF, you need to be able to go back and forth, right? So PDF will find the CDF, CDF will find the PDF. Here, right? Okay, so let's take a look at this ones here. How do I graph the PDFs? So let's try to graph the PDF. Okay. So this is a 1, 2, 3, 4. Okay. So this is 1/3. Okay. Okay. So this is 2/3 if you want. Okay. Okay. So now between 0 and 1. Right, so between 0 and 1 is 1/3. So let me try to use a different color, maybe it's good. Okay, between 0 and 1 is 1/3. So it's this, right? Okay, then 1 and 2, what happened? Okay. So this is lines, okay? So between 1 and 2 is 0, so it's nothing here, so it's zeros here. Then 2 and 4 is another 1/3, so it's from here to here, right? So this red one, this is my f of x. So if you take a look at the area, so it is this PDF, right? Because this is 2/3 area, this is 1/3, right? When you add them together, it is what? It is 1, right? So if you just do this, okay, so if I kind of do this here, so here, right? So this is the area, right? So one area is 2/3, one area is 1/3. So you know it is the PDF. So I did it right. Okay, so now this is pretty straightforward, right? Okay, now the CDF is here, right? Okay, let's take a look at the CDF here. Let's do the graph. Okay. Okay, so remember what is the CDF? Let's try to do a brief review here. And that's what we did in the previous, right? So the CDF is a capital, capital F of x. So it is the integration from the negative infinity to x and f of t dt, right? So, so when you integrate the PDF, it will give you the CDF, right? Okay, so now let's start it. Okay, so now let's start. Okay, so the first one's here. Oh, I need to mark this is 1, 2, 3, 4. All right. Okay, so now let's try to do here. All right, so the first one's here, I need to look at the first areas, right? So it's between 0 and 1 here. So I know the f of x, remember use the definition, f of x will be equal to the integration from the 0 to the x, and this is 1/3 dt, correct? Okay, so if you do the integration, so this is will just be x over 3 here. Okay, so this is, I integrated x is from 0 to 1 here. Okay, so now let's try to graph it, right? So this is y equal to x graphs, right? So this is f of x equal to 3x, x over 3. So here, that means x over 3. So when the x from the 0 to 1, so the if x equal to 1 is 1/3, x equal to 0, so it's a line, right? So it's this line, right? So when x equal to 0 is 0, when x equal to 1 is 1/3. Okay, so this is the first part. Okay, now let's take a look, right? So in here, I don't have anything. It's 1 to 2. You know, I don't have the, you know, the f of x is zeros here. It's nothing defined here. So you remember the f of x is a continual adding, right? So during this period, during these areas here, let's try to, okay, so during these areas here, right? Okay, so during this area, the PDF is 0. So that means my f of x, my CDF, has nothing to add, correct? So that means what happens here, so from 1 to 2, my CDF will stay flat. All right? So my CDF will stay flat at 1/3. Okay, so understand that? Okay, so now that's what happens here. So I can write out my second part. So I know that, let me use the same color pencil. So I know my f of x is remained 1/3 because I'm continue adding, right? So this is what? This is when the x is greater than or equal to 1 and less than or equal to where? Less than or equal to 2 here. Okay, now I'm going to take a look at the next regions here, right? So the next region, this is f of x is equal to, you integrate from 2 to where? 2 to x, right? Then you have 1/3 dt, correct? Okay, so this is 2 to 4. But, you know, I'm starting because my range, my domain started at 0, right? So I starting at 1/3. So I already jumped to the 1/3. So I need to add what? I need to add 1/3. All right, this is super, super important. And I think a lot of students, they get confused because they forgot to add 1/3. It's because your PDF, your CDF is already started at 1/3. So you are thinking the next regions here. Okay, so now let's take a look at what is my integrations here. So this is the integration is easy, it's x over 2. So this is 1/3. So this will be 1/3, right? X minus 2 plus 1/3. So this will be 1/3 x. So this is negative 2/3, so it's minus 1/3, right? Got it? Okay, because this one's here, this is minus 2, so this is why the distributive property will give you negative 2/3, so plus, so it's negative 1/3. Very good. Okay, so now, so this is, 1/3 of the x. So what is the x here? This is x is from the what? From the 2 to 4s here, right? Okay, so now let's try to graph it and see if we'll be able to graph it. Okay, so when x equal to 2, what is here? X equal to 2, right? So if x equal to 2, then the f of x, f of 2 is here is what? It's 1/3, right? So yes, so that's why I start here, correct? Okay, let's take a look. When x equal to 3, what happened? When x equal to 3, the f3, because 3 minus 3, 3 over 3 is 1. 1 minus 1/3 is what? Is 2/3. So that means I jump to here. Then when x equal to 4, you can choose few points. So this will be f of the 4. So this is what? 4/3 minus 1/3. So it's 3 over 3, so it's 1. So it's reached to 1 here. Right? So that is, because this is the lines, right? So this is the line. I hope I can draw a line, right? So this is the line because the CDF is a continuous increasing. And then, of course, after the 4, they already reached the 1. So it's going to be flat at the 4 because then when you add everything, when you integrate everything together, after each domain will be 1, right? Okay, so that is what is the CDF, right? Be very careful. It is, this one is very good. So the way you can write it, so summarize, right? All your things here, you can say if this will be 0 when the x is what? X is less than or equal to 0, and it will be x over 3 when the x from the 0 to 1, then it will be 1/3 here, right? So 1/3 is here when x is from the 1 to 2. And then in here, this will be 1/3 of the x minus 1/3 when the x is from 2 to 4, then will be equal to 1 when x is greater than or equal to 4. All right, so be very careful. This is how do you write it out, your PDF, CDF, right? It's very important. Like I say, if you understand these problems, I think you are pretty good shape to understand how the CDF and the PDF switch back and forth. If you still have questions, maybe you want to, review this video more about this problem. Okay, let's take a look at the next problems. I think the next problem is a very good problem also. And number 5, number 6 are a little bit difficult, but if you understand, I think you will have a very good understanding about the PDF, CDF. Okay, so in here, this is the distribution function. So this is the one we're going to, this is a givens, right? So what is here? This is the CDF, right? So it's given the CDF, then they want us to find the different probability and the different values here. Okay, So now, first things here, so let's try to do a graph. When you do a graph, I think that you will get a better understanding here, right? Okay, let's do the graph of the f of the capital. Okay, so this is a 1, 2. This is a negative 1, negative 2, right? So this is 1, 2, 3, negative 1, negative 2, negative 3 here. And so this is, let's say this is 1/2, this is 1, this is 1/2, this is 1/4, this is 3/4, right? Okay, let's take a look here. Okay, so f of z equal to 0 when the z is less than negative 2. That means you go this way, right? So that means you go this way here. That means here is the, right? Because it's zeros here, so we don't care. Okay, now let's take a look here, right? So between the negative 2 and the 2, let's see what happens here. Okay, so when so you plug the number, okay, so you plug the numbers here, z equal to negative 2. You plug into this formula, so what is your f of negative 2 equal to? Your f of 2, negative 2, is equal to the negative 2 plus 4 over 8, right? So what is here? It's 1/4. Oh, I see. So negative 2 is 1/4. Oh boy, I see my, I see my CDF jump 1/4. All right, okay. So let's take a look next ones here. Okay, let's take a look at when z equal to 0. See what is my values here. So the f of the 0, so if you put the 0 is 4 over 8, so it's 1/2, right? So that means it's in here. Okay, now let's take a look at the another end, negative, the positive 2, right? Okay, so now let's let me put it in here. So when the z is equal to the positive 2. Okay, so they're close to, so then the f of the z is going to what? Going to be the 6 over 8, so it's 3/4. Okay, so now, let's see here. So this is 3/4 here, right? So when you plot it, okay, so this is the f of z. Okay, now when the, okay, so I need to be careful here. So here, okay. So because it's not equal, right? So here we don't have the equal signs here. So I need to be careful here. So this is 3/4. It's a circle. And here, okay? Okay, now let's take a look at the last ones here. When the z is greater than or equal to 2, right? So when the z is greater than or equal to 2, it's 1. So here, this is a circle, right? Because I don't have the value, don't have it here. Then greater than or equal to 2 is 1. That means this will be my, this is the CDF, right? So this red ones here, this graph is the CDF here. Okay, so this graph is the CDF. It's because they got a jump here, right? So this is one, so this is the 1/4, right? So they start to jump up. So I know what happens here. So that's why I know here probability of the z is equal to -2. Right? The probability of the z is equal to -2. You got to jump here. So what is here? This is the 1/4. All right. Then the same way from the probability, the z is equal to the +2. What happens here? You got to jump here, right? So this is another what? Another 1/4 here. So far, so good. Okay. Now they want us to find the probability Okay, so now the next one here is we want to find the probability -2 the z to the 1s here, right? So because this is my densities, right? So this is my CDF. So this will be equal to f of the 1 minus f of what? -2 here, right? So the f of the 1, so that means what? So this is 1 plus 4, so it's 5, 8 minus what? F of -2, we just did is minus 1/4, right? So this is 1/4, so it's 2/8. So what do we have here is 3/8. It's clear? Okay, very good, right? Okay, now the next thing is here, if I want to find 0 greater than z and less than equal to 2. Okay, so here, be very careful, right? My CDF does not include equal to 2 here. So this one, I need to change that. So this is z less than 2 plus the probability of z equal to 2. Correct? So the z is less than 2. So what is the z is less than 2 here. So that means I'm going to use what? F of 2 minus f of what? 0 plus probability z is equal to 2, right? So f of 2, right? So f of 2 is what? F of 2 here, we did here is 3/4 minus f of 0. F of 0 is what? Is 1/4. And plus z, this is 1/4. So what is the answer? 1/2 here. Okay, so this one's here, my f of z, so my PDF, this is a very interesting PDF. This PDF is the combination of the discrete random variable and the continuous random variables here. Okay, so let's try to write it out. Okay, so here is, okay, so I know my f of x. Okay, so this is my f of x here, right? Okay, so here, the first one's here, this is 1/4 when the z is equal to -2. Okay, so what, I shouldn't say x f of z, right? Because this is a z. Okay, so now what is the value when the z is from the -2 and to 2 here, right? So that means you take the derivative. Remember, the PDF is the CDF, you take the derivative. So this is 1/8. Okay, so here, I should have said here, this is the, because it's, so this one's here. So this is, doesn't have the equal sign. And now, the next one's here is when the z equal to the +2. So it's equal to another what? 1/4. So as you can see, this PDF, this part, right? So this part is the continuous one, and then these two are the discrete one. So this is the combination of the continuous random variable and discrete random variable. It's very good problem. It's very, the CDF, PDF is very easy, but it's very good problems. It's very good problem to test your understanding about the CDF and PDF concept, right? How to flip it back and forth. Like I say, it's extremely important because we need to have a very strong foundations for the single variable, because later we're going to talk about the joint random variable. So if you have 2 or 3 together, then how to find the CDF, how to find the PDF, it's really all go back to your fundamental idea. Okay, let's take a look at our last problem here, right? Okay, so this last problem is the total lifetime for a 5-year-old dog of a certain breed is a random variable and whose distribution functions is given here. Okay, so distribution function. So this is what? This is the CDF here. All right. Okay, so now I want to find the probability, say such a 5-year-old dog will live beyond 10 years. Okay, so let's see how do we do that. Okay, so the first ones here will be easier if you write it out. So that means I'm looking for is greater than 10 years. Correct? Beyond 10. But what is the, so if I want to use this CDF here, so how do I do that? I know the CDF, right? So let's review again, right? So the CDF, this is the f of x, is you integrate your PDF all the way to the x. That means it's less than x, right? So here, in order to use this CDF function, I will say this will be equal to x is less than equal to 10. Correct? Okay, so if it's x is less than equal to 10, then I say, oh, okay, then this one's here is my CDFs here. Then I can use my CDF definition. So I will just directly plug into here. So it's f of 10. So this is 1 minus f of 10. So this is 1 minus 25, 10 to the what? 10 to the squares, right? So this is 25 over 100. So this is 25%, right? So it's 1/4. And so it's 25%. Okay, now let's take a look at part B here. They say less than 8 years, right? So that means what you're doing here is less than 8 years. Oh, that's good. That's the probability. That's the CDF. So I can just directly say it's f of 8, right? Then you say, hey, this doesn't have an equal sign. Doesn't matter because this is continuous. The equal sign, will be equal to 0, right? So this is f of 8. Okay, so this will just directly plug in there. So this is 1 minus 25, and this is a to the square. So this will be what? So this is the 39 over 64. Okay, now let's take a look at the last ones here. So the last ones here, anywhere from 12 to 15, right? So here, this is you want to do is from 12 to 15. Right, so from 12 to 15, so this will be equal to your f of the 15 minus f of the 12, right? Right, because like if this is 12, this is 15, f of the 15 is you add everything up to here, right? So this is f of the 15, we talked before. 12 is you add everything up to here, right? This is f of the 12. Right? So you minus, you will get this one. That's why we minus. Then you just plug in into your CDF formula. So this is 1 minus 25. This is 15 to the square. Then minus 1 minus 25. And what? This is 12 to the square, right? So you will get the answer if you use your calculator or just do manually, you will get it's 1 over 16. And that's it. So for these problems here, the key things you learn from this problem seems easier than the previous 2 problems, right? But the point here for these problems here, every time when you do the statistical problem, the word problems here, is this good? They want, try to write it out, your word problem, two equations. Like we say, beyond the 10. What's that mean, beyond the 10? So write it out, is x is greater than 10, right? So after you write it out, then it will be pretty easy. Then you say, oh, okay, now I'm using the CDFs here, right? So this is the problem, and try to let you practice, make sure for the word problem, how to solve it. I always, kind of told my students here for the statistical word problem, you need to read it very carefully. Then you kind of like a translator. You translate the word problems into the existing formula or the equation you can use. All right, that's it. And this is the lecture about the continuous random variable for the for the continuous random variable, and then you want to find the PDF and the CDF. Like I said, you need to have a very good background about the CDF and the PDF, how do they go back and forth, right? So CDF to PDF, PDF to CDF. And that's it. All right, so if you have any question, feel free to leave me a comment, or you can send me an email, and my email address is shikomathslab@gmail.com. All right, so that's it. And next lecture is the one like I just talked about. I'm going to expand this into a 2 or 3 multivariables here. Now we're going to take a look at how about the PDF if I have 2 or 3 random variables combined together. It will be very interesting. Okay, so it's nice to talk to you. Like I said, this lecture and the previous lecture, so about the discrete random variable and the continuous random variable are very, very important lecture. Those are the foundations for the later, all right? Okay, so make sure you fully understand the difference between the CDF and the PDF. All right, that's it. It's nice to talk to you, and you have a good day. And I'm going to stop here, and I'm looking forward to go to our next step to see how about if I have more than 1 or 2 variables there. All right, so nice. Okay, bye, and I'll talk to you later.